sir, what exactly we are going to learn today?
So sir, today I'll try to illustrate Newton's first law, as I think everyone would understand that Newton's law is one of the most basic stuff that we study in physics. So let's try and give you a challenge. You just have to make sure that without touching this coin, you have to make sure that this coin falls out of this box.
I guess it's easy. Let me try it.
Try it out. Now, as you would have seen, that coin fell right there. Why? Because alright students, as you guys just saw an illustration in which we experimentally proved something on the basis of that if a force is not applied to a particular body, it will always tend to remain in the state of rest. Now, this is nothing but Newton's first law. Now, I hope every one of you must have heard of one of the greatest scientists of physics, that is Isaac Newton. And what was this basic law? And this is what on the basis of what entire physics is based on. Now, going to the statement says that an object will remain in state of rest or uniform motion. So, uniform motion? Uniform motion is nothing but if a body is moving with a certain speed. Remember that it will try to move with the same speed without changing its speed. It will continue doing that until and unless an external unbalanced force is applied on it. Right? Now, let's go through it again. So it says that a body which is at rest or is in motion, it will be in the state of motion or rest until and unless an external force. Now, I also said one more thing, that this external force should be unbalanced. So why do you say that this force should be unbalanced force? Now, reason is, students, let's suppose, if I apply two forces, equal and opposite. Now, I hope in your previous grade you must have heard this term called balanced forces, right? Now, if a particular body experiences balanced forces, now we see an example that here's a football, and if three people are trying to push it, but what you see that football is not moving, so that means the net force, and here there is a term also that we use, which is called vector sum, right? Now, what is vector sum? For your level, you can just keep it in mind that it is sum of all the, or you can see the result of all the forces that are basically exerted on the ball. Now, if there are three certainly forces from different directions acting on the ball, and you see that ball is not moving, what we can basically conclude, that body is basically experiencing balanced forces. Now, if there are balanced forces, that means unbalanced forces are required simply to change the state. The state of the body will not change because in this case, you can say these forces are balanced forces. I hope the law and the first point that we are trying to make here is very much clear to you guys. Moving on. Now, they also call this law of inertia. Inertia, yes, a little tricky term, but basically very easy to understand. If you ask me personally, sir, what is inertia? Inertia, students, is nothing but the stubbornness. So stubbornness, the stubbornness of a particular body to say that I want to be in the state of rest. If I am in the state of rest, body will say no, I want to be in the state of rest. And if a particular body is moving with a certain speed, that body will say, no, I want to keep moving at the same speed. But guys, remember, this property, the resisting property of a body that I don't want to change, this is called nothing but inertia. But this stubbornness, this resistance can be overcome by something called force. So, why do we call this law of inertia? Just read it out. A body continues to be in its state of rest or uniform motion along a straight line unless an external force is applied on it. Now, understand inertia in itself means what? It means that it is the resistance of the change. Resistance to the change. So body will always try to resist the change. Either it is in the rest or in the motion. From there we get the term inertia. Now, always remember, there are three types of inertia. One is inertia of rest, inertia of motion, and then we have inertia of direction. Quickly, I'll explain it. If a body is at rest, the body says, I don't want to move. Let me be in the state of rest. Now this body basically has inertia of rest. You just saw an example before the lecture was started that the coin had inertia of rest. The coin said, I want to be in the state of rest. However, that is why the coin fell down. Similarly, a body has inertia of motion. One of the very basic examples, you must have seen, if brakes are applied in the car quickly, someone instantly applies the brake, what do you experience? You tend to fall forward. Now, when you fall forward, this is because your body has inertia of motion. Initially, your body will be like, no, I want to be in the state of motion, but then obviously you come in rest. Obviously, who does that? Seat belt, right? Seat belt applies a force in the opposite direction and stops you, right? So initially your body had inertia of motion, which was overcome by the force that was exerted by the seat belt of the car. Moving on, inertia of direction. Similar way, you must have seen, when you're driving in the car or traveling through bus or any particular automobile, when you take a turn, every person tends to go towards that direction, right? So if you take a left turn, you will see that your body will tend to go towards right. Now this is what? Inertia of direction. Your body tries to resist the change in direction. Your body says, if I was going straight, let me go straight. But when you apply this force and your car starts to turn, then you change your direction. To resist that, the inertia of direction of your body would try to push you towards right. But again, what you do, you hold on to something, you make your body straight. How did you overcome the inertia? By applying the force that is your muscular forces. I hope this small topic but very interesting topic, which I believe you guys can even see in your surroundings, would be very appealing for you guys. Thank you so much for coming.